Hey everybody, I'm making a part 1.5 video real fast because I realized in filming the second part of the second lecture that I forgot to actually address a couple of the other rules for exponents, and they're going to be handy later, and they can cause some issues if you don't know them. So we're just going to break into them real quick and knock them out. So we got two rules. Let's go back up here for exponents. So our first rule will be called power of a product rule. And what this is stating is that if you have A times B and you raise it to the M, right, then that's going to be A to the M times B to the M. And that's important. It's very important for making sure that all your math is correct and everything in these problems that we do. So if you have a like a 4, or matter of fact, we'll take it back to our 2's, which we were doing in the previous example. If we have a 2 times 2 raised to the 4, let's not do that. Let's do it 2 times 2 raised to the 2. Okay? Essentially, what we have here, based on this, we could simply say it's 2 raised to the 2 times 2 raised to the 2. We just distribute this down. But let's work it out and see what it comes out to. So essentially what we have here is we have the number 4. 2 times 2 is 4 raised to the 2, which equals 16. Now let's see, 2 raised to the 2, that equals 4. 2 raised to the 2, that also equals 4. 4 times 4 is 16. So we see how this works. And the other one is the same rule basically for the quotient, or for fractions pretty much. It's called the power of a quotient rule. And it's stating that A over B is equal to, raised to the M, is equal to A to the M over B to the M. And same rules apply. If you work it out the hard way like I did above, you'll see that it's true. Now, I want to address real quick where I see a lot of issues with this is somebody will be converting, let's say they'll be converting 1 foot squared, and they want it to go to inches. So they will just go ahead and say 1 foot squared. Okay, well, we know 1 foot squared is 12 inches squared. And that's actually incorrect. That's actually incorrect. Right here, we have to use our power of the product rule. That's going to be 12 inches squared. And we carry it down. And that becomes 144. Well, here, let's not solve it just yet. Let's say it's 12 squared inches squared, which becomes 144 squared inches. Now, this makes sense if you think about it. Imagine that we're looking at an area. Okay? We have this box. And this box is made up of 1 foot. This is 12 inches long. It's 1 foot. And I'm sorry if you hear my phone going off in the background. And it's by 1 foot. So this is a 1 foot by 1 foot box. Now, this side right here, that'd be 12 inches. So we're just going to draw a line. 1, 2, 3, 4, 5, 6. And we're going to give it one more. Didn't really make it fit there, but that's all right. We can clean this up, right? We'll just give it a little eraser job there. That's 12 inches. Now, going the other way, we have another 12. So we're just going to imagine, I'm not going to actually count this, but then you have to do it all through here for each of these lines. You see, 12 squared inches doesn't make any sense. This is 12 squared inches. If it was a box like this, divided 12 times, however many that's going to be, and it was 1 inch by 1 foot, this would be 12 squared inches. So you have to keep that in mind when you're, and the same thing applies to if we were doing a cubic foot. 1 cubic foot is equal to 12 inches cubed. And then you carry it in. Okay? All right, thank you guys very much.